Sri students. Today we'll be learning about gravitation. So this is lecture number one. It's lecture number one on gravitation. First of all, students, let's learn what is gravitation, or we also call is, in case of Earth, we term we normally use the term gravity. What is this, students? You see, this is Earth. Everyone knows that Moon is the natural satellite of Earth, and Moon is constantly rotating around the Earth. Now the question is, what is the force which is binding the Moon, or which is compelling the Moon to rotate around the Earth in this nearly circular path? Once we understand, then the question is, there are so many planets which are moving around the sun. Then there are millions of other heavenly bodies which are also moving around. They are in constant motion. They are in constant motion around some object in the center. So what is the reason for this motion? How this motion is created? So let's understand this by a simple example. You see, this is a boy. So he's having this stone. This is a stone tied to a string. So there is a tension in the string. Tension means there is a stretching force in the string. So what he is doing, he is rotating this stone, with the help of which is tied to this string. So this is in circular motion. Stone is in circular motion. So basically, you see, if there is no string, if the string is not there, this stone will not move in circular motion. So the reason for this stone to be moving with a constant speed, but different velocities at every point, which is moving in a circular motion, is the pull or the stretching or the force which is always binding this stone towards the center. See, there is always a pull, whether the stone is here, even here it is being pulled towards the center, whether the stone is here, wherever the stone is there, it is constantly pulled towards the center, whether the stone is here. So if there is no pull, suppose this boy leaves the string, what will happen? If this boy leaves the string, this is tangent to the circle. Though it's looking like a ellipse, but actually it's a circle because it is drawn on 2D plane. So this is tangent to a circle. A tangent is a line which touches the circle only at one point. So if this boy leaves a stone, it will, fly off tangent to the circle, tangent at this point. So ultimately what we learn, that it is because of the muscle power, this muscle power of the boy. Because of this muscle power, the stone is constantly circulating in the circular path. Well, that force which is provided by the boy, the hand of the boy, to always pull the stone inwards towards its hand by the help of the string is actually the force of gravity on larger scale. It is the force of gravity, or in other words, we say gravitational force provided by the earth on the moon. There is no string here. There is no string here like this boy, but there is a gravitational force. There is a gravitational force. Imagine there is an imaginary string, and this moon is like a stone. It's always constantly pulled inwards by the gravitational force. This is the gravitational force. So, students, it's very interesting to note that Earth is having gravitational force. Earth is exercising gravitational force on the moon, not only on the moon, but even on all the man-made satellites. We have launched so many satellites. They are also orbiting around the Earth. May not be in the same orbit. I've wrongly drawn. They may be orbiting around the Earth in different orbits. These man-made satellites. So these man-made satellites are also being constantly pulled by the center of the Earth. Again, there's no string. Now, the interesting thing is all the man-made satellites and this natural satellite moon, they are rotating around the earth because of gravitational pull of the earth, or you say the gravity of the earth, and the vice versa. I believe the rotation is causing the gravity, and gravitational force is causing the rotation. So here we define gravitational force. So gravitational force is not only exercised by the earth on different objects. Rather, the gravitational force is there exercised by sun on all the planets moving around the sun in different orbits. The sun is also supposedly like the sun also has a, you can say, uh, a imaginary string, tied to all the planets, and like this boy is using the muscle power to rotate the stone in a circular path. The sun has its own gravitational force, which is being exercised not only on one but all the planets, including Earth, Venus, Mercury, Saturn, and because of that they are moving around the earth. So it's because of this power of the earth, the sun, that they are moving around the earth. In other words, we can also believe that this rotation is also responsible for putting everything as they are. Okay. So, and they also believe, some scientists, that this rotation is slowing down with the time, possibly giving an indication for the death of the universe also, for the collapse of the universe also after time, maybe long time. Okay. So now the question is, can we measure this force of gravitation between Earth and the Sun? Can we measure it? Or can we measure the force of gravitation between the Moon and the earth? Or in a very simple way, can we measure the force of gravitation between the hand of the boy and this stone? Yes, it is possible. So that is given by Newton's law of gravitation. Okay. Another thing I would like to mention here is sometimes, we talk about gravity and sometimes we talk about gravitation. Is there any difference? Not really any difference between gravity and gravitational, but sometimes we say The gravity is more used for the force of attraction on the bodies which are in the atmosphere of the earth. So all those bodies, they they fall on the surface of the earth because of gravity. In other words, it's a gravitational force also. But you see, moon and other man-made satellites, they earth is also exercising gravitational pull on all of them, but they are not falling on the surface of the earth. So a little bit of difference, but mostly they are all same. Okay, how can we measure it? How can we measure the gravitational force? That is another thing we want to learn. Give me a second. Yes, students. Now, this is what we call as Newton law of gravitation. Newton's law of gravitation. So there were a lot of scientists like Kepler and other scientists also. They worked a lot on this, and kind of you can say that Newton summed up whatever they did into this gravitational law, beautiful law. Okay, Newton's law of gravitation and second law of motion, they're also to some extent related. So now let us see, students, that this is one body. Its mass is m1. You can say this is sun or earth also. This is another body. Its mass is m2. Okay. Now this point, you can say, students, this point we can consider as a center of a second body, and this point can be considered as center of first body. Let's say the distance between two centers is d. You can call it r or d in meters. M1 is in kg, M2 also is in kg. Very simple. There is a force of attraction between these two bodies. Not only between Earth and Moon, not only between Sun and its planets, but even between Sun and all the infinite number of stars in the universe. Then all the infinite number of stars and the Sun and the Earth, between all the infinite galaxies and galaxies. So you can talk about any two heavenly bodies, and there is a force of attraction between them. Okay. So our observation that Earth is attracting so many things towards its center is expanded to all the bodies in this cosmos, in this universe. They are attracting all other bodies. And what is a force of attraction? Newton observed that this force of attraction is directly proportional to product of masses m1 m2 and inversely proportional to the square of distance between them. This is also known as inverse square law. Students, if this is the thing, we can sum up f is equal to g m1 m2. G is a constant divided by d square. This is universal law of gravitation. Here the value of G is is 6.67 into 10 raised to power minus 11 Newton meter square by kg square. This was my first lecture. Next lecture we'll discuss numericals based upon this. Thank you very much, students.